right, welcome. My name is Björn. Thank you. I have done one thing or two for Prometheus over the last 10 years or something. And I would like to talk about PromQL for native histograms. Thank you for the first question. I could sense that this is exactly what you need now. This talk is only here for the people who are watching this in the future in the recording. If you watch this as a recording, please watch Ganesh's talk first because it sets the stage for this talk. If you're here in the room, you have just seen Ganesh's talk. But there's another talk of Ganesh from KubeCon in Valencia earlier this year, which is very similar to kind of Ganesh's talk from today and my talk combined. It's just like approaching things from first principles, while this talk is fairly hands-on. So it might still make sense to watch also this talk to see kind of the other perspective. And if you are really into Prometheus histograms, I've given tons of talks about this, and these are the three most important ones, which I like to call the original trilogy. And like with popular movie franchise, it also has prequels and sequels. This is the recommended viewing order. But you can see this one has been produced after the second one. But yeah, by the way, the first talk also answers a bit of this question, what are the problems with the text format? It gives you a lot of historical perspective and also a lot of background. What was our thinking process? Why did we decide to do this? Why did it take so long? Like this is from like the second talk there is kind of the centerpiece, and it was given here in Munich at the last in-person PromCon, and it's 3 years ago. And even back then, we were already talking about the past and history, so this has a lot of history. Hazard warning, Ganesh said this already, but since you might just watch this on the recording, this is all very experimental. You need a feature flag to activate native histograms on Prometheus. Don't try this in production unless you really know what you're doing, because it might break in weird ways. Also, this feature flag is only gating ingestion. So if once the native histograms are on your TSDB, they won't go away anymore, even if you remove the feature flag. Don't do this to your precious production TSB data. PromQL. A bit of background. PromQL is, if you want, a statically strongly typed language, just that the types are weird. The types are instant vectors and range vectors. You probably have never heard about those types in other languages. There are scalars and strings. They sound more like types. Let's look at those in more detail. Strings. It's on the slides. This is from the Prometheus documentation, Holy Scripture. Essentially, they say that strings are unused. It's kind of a bit unjust because there are strings in PromQL, right? There are string literals, and there are strings as inputs for some functions like label replace and stuff like that. They just never happen to be a result of a PromQL expression. But you can type in the literal, you can type in quotes, hello world, and the Prometheus UI will put this, like, you get this back, right? Hello world in the Prometheus UI. If you've never tried this, you can do it. It's kind of useless, but it's fun. You cannot graph it. That's why I put this thing there. How would you graph a string, right? If you try, it will give you an error, and you could call this a compile time error, right? I mean, it's not really a PromQL compiler, but that's why I call it statically typed, because just by looking at it, you can already see there's a type mismatch. You cannot graph a string. Scalars, you can graph scalars, hooray, it's just boring, just straight lines, and you can use scalars to abuse your expensive Prometheus server as a pocket calculator. That totally works. But then we come to the weird stuff in PromQL. This is up, right? This is the most famous time series, and if you just type it into your expression browser, you get a vector, an instant vector. It's just one point in time, and of course, all those samples come from different points in time in your TSDB, but Prometheus just selects one that is like the closest in the past and gives you this vector where every element has a different label set. That's an instant vector. And then there is a range vector, which you probably haven't used a lot as like a naked range vector. It's usually an input to other functions. But in case you never did this, you can render this in the table view. And it's actually quite good for debugging because you see precise timestamps here, right? So you get a number of samples and you see the timestamps from the TSDB. So it's sometimes quite handy. If you try to graph this, again, compile error if you want, this doesn't graph. Okay, so that's how the world looked so far. Now histograms. How do histograms fit into this type hierarchy? Do we now have, I don't know. Let's first look at how histograms are represented right now. Ganesh already showed you that. This is how it looks in the Prometheus web UI. You can't even display just a single histogram. The histogram, in this case, would be called request duration seconds, but that name never shows up. That's how we emulate histograms so far. We just break them down into bucket time series and a sum and a count time series, and to display them all in one, you need like this weird hack, this underscore underscore name underscore underscore hack. If you have never used that, you can abuse this to match multiple names because the name is just a hidden label in a way. So in that way you can display a histogram. You see how it looks like right now, and this is also why we call the new ones native histograms, because this is kind of non-native emulated histograms. They kind of fly under the radar. We don't have first-class histogram types. We just have those time series of floats, and they fit into the type system. Okay, now we need some new types, right, for the new native histograms. But native histograms will still be in instant vector and range vectors. Should we introduce new instant vectors, histogram instant vectors, and perhaps even histogram range vectors? We thought about this, but in the end, it doesn't really work. We came to the conclusion that the histograms versus float samples, they open up a new dimension in typing, and they even open up a new flavor. It's kind of like dynamic typing. So let's look at this. Instant vector, now it's really bad because I only see this there. Instant vector is a set of time series containing a single sample for each time series, all sharing the same timestamp. That's just from the documentation. And now we have to add another sentence. Each sample is either a float, as we know it, or a fully fledged histogram. Ganesh had a very nice slide where you could see this, right? What was just a number is now this whole rich structure. So this can be either, right, which is the dynamic part. It's like a dynamically typed language like Python, where a variable could hold float or an object or a string or an integer, right? It's kind of a bit similar. That's why there are big and fat quotes around static and dynamic. For range vectors, we have to go even deeper. So range vector is a set of time series containing a range of data points over time for each time series. Each data point consists of a timestamp and a sample, and each sample, again, can be now a float or histogram. This is like fourth dimension or something. If you look at this in practice, it becomes much clearer. So this is now with the feature flag enabled and the new client Golang 1.14. And then you ingest a histogram that is called request duration seconds, and you can just type in the name and you will see the new histogram. And you see what was just a floating point value here on the right is now a whole complex beast. Curly braces, we have like a count, we made up a syntax for that, right? Count and sum, like fields in an object, but then also we used stylized mathematical open and closed interval notation to tell you this bucket is like from 0.5 to 1 has 38 samples. This is essentially what Ganesh showed you in graph. and it's a wall of text. This is schema 0. It's a very low resolution histogram. In real life, your resolutions will have higher, your resolutions will be higher, and this will have a lot of numbers. This is why in the future we would like to have something like this. Of course, probably wouldn't look like this, but some SVG rendering in the Prometheus UI that shows you a graphical representation, and then you can hover over it or click on it, and then you get the wall of numbers. That's kind of the future. This is a range vector, and again, a range vector can also have histograms, and it gets out of control here, right? Now you see 3 samples here with timestamp, and every sample is this gigantic structure of a histogram. But yeah, for debugging purposes, you might want to inspect it. If you actually have more than one element, so far it was only one element. This is now the full vector without any label matchers there. And you see there is a more realistic histogram, schema 3 or 2, which has a lot of pockets. And you see how this looks like. It's just a single histogram, wall of text. This is our low resolution histogram. And what's that? That's a little rogue counter. Somebody made a mistake, didn't name the counter properly, and request duration seconds was defined as a counter on one of the targets. And that's where this dynamic typing comes into the game. You cannot prevent targets from doing this, right? It's kind of not the convention, but if people do this, this is what you have. You have now a mixed vector. Some elements are histograms and some are still floats like before. All right. What happens if you click on graph on this one? You can graph this, but it's not what you want, right? This just graphs the count of the histogram. So for the normal counter, it still works. For the real histograms, you just see the count. That's not what you want. How do you graph histograms? You could color code the bars instead of making them higher or not so high. You can rotate at 90 degrees, and then you put one of those color-coded histogram after another. Sounds weird, but what you get is a heat map. Again, this is the future. It doesn't work yet. I just did a screenshot from a Grafana heat map. So Grafana has a heat map panel and already supports the experimental native histograms, but we want this in Prometheus proper, of course, one day, right? So this would actually be just a single histogram, so you need even a panel of many little heat maps to proper graph this. It's still a matter of research. Okay, now let's do real PromQL, because that was the question we had after Ganesh's talk. What is the most important operation? PromQL, our beloved rate function. And you can rate a range vector, and a range vector can now also contain native histograms. So you get a range vector of histograms, and then you get rated histograms from it, and they look like normal histograms, just that now they might have, here you see that. What was just an integer count in the bucket, Ganesh mentioned that. If you rate it, you get weird values there, but that's a rated histogram. Another rated histogram, and this is the rated counter. It works as expected, right? So the rate function detects variable, like dynamic typing. Is this a histogram? I will rate the histogram. Is this a float? I will rate the float. The fun thing is, to demonstrate the sparseness of histograms, this is just the same query, and half an hour later, when my simulated traffic that I used for this example stopped. So if you have no traffic at all, the rate is 0, count is 0, sum is 0, and all the buckets are 0. Buckets that are 0 are not represented. That's the trick, how we save resources, so the buckets all disappear. If you later put this into a recording rule, not possible right now, but soon, then it will be very easy to store if there's no traffic. Before, every bucket was still there, and it was a mess. Okay. Operators. Only very few selected operators work with histograms, but they will get you most of the way. What works is addition. You can add one histogram to another. It's not terribly useful in general, but the primitive works. You can also see here in the result that this was a high resolution and a low resolution histogram. And as Ganesh explained, how this works behind the scenes, here you see it in practice, you kind of consolidate to the lower resolution, and then you get the result. This is essentially the one slide from Ganesh's talk is the theory, and this is how it looks in your expression browser and in PromQL. Way more useful than adding two histograms is the aggregation operator that adds everything together, which is called sum. So with sum, just the name, you sum it all up into one histogram. Sadly, empty query result. Who knows why this is an empty query result? Yeah, he got it right. It's a mix. So dynamic typing, right? Like in Python, if you try to, whatever, multiply a string with a integer, whatever, that might even work in Python, I don't know. But like you cannot add a counter to a histogram, so you get an empty query result. There should be a big and fat warning here, of course. You try to aggregate a normal float with a histogram time series. This will happen in the future. We still need to communicate this up the stack. This will also be used, it's a much requested feature, to communicate that you have a rate and you have only one sample in your range vector. That's also something that we need anyway. So this plumbing will be installed, and then you get a warning. But it's kind of similar behavior as before. When a label match doesn't match, or you only have one sample in your range selector, then you just get nothing, right? So here I filtered out the rogue counter with a normal label selector, and now it works. This is the one histogram that sums it all up, right? From now on, I'll remove the row counter so we can just use normal expression and it will just work out fine. Yeah, so this is, you sum it up. Of course, it was here, right? Yeah. There, I quote myself, the proverb, right? First the rate, then aggregate. So I'm aggregating here and I have not taken a rate first. This works with so-called gauge histograms, which are a story for another day. It was already mentioned by Ganesh. You could ingest them, like some targets expose gauge histograms, but usually histograms are counter-like, so you want to rate them first. You also want to slice and dice, and since partitioning by labels is now actually affordable, as we have learned in the previous talk, you should also do it, right? So you can now have your HTTP request latency histogram, you can partition it by status code, by HTTP method, and then you can slice and dice as you are used to it from counters. So these are typical expressions that you would use. They look very natural, you almost don't notice that there are histograms behind the scenes, and the output of these expressions is a histogram, so you would show them, graph them in a heat map, which works natively in Prometheus in the future, but right now it already works in Grafana. All right, but we also want the other killer feature of histograms, which is Quantile, right? Quantile estimation. On the left side, okay, it's kind of getting small, but I hope you can see this in the recording. Left side is how you would do it right now with like this weird LE label, and so you have to keep the LE label in the aggregation, and you have the underscore bucket magic suffix, and then you do this, it works. On the right, it's the shiny new world. It's kind of more intuitive because you just sum and rate the histogram, and then you call histogram quantile on it. Again, the function will detect if this is a native histogram or a conventional bucket. And the graphs look very similar, just you have to trust me. On the right side, it's the more accurate graph. That represents reality in a better way because they have higher resolution, they are more accurate, and the left one is like a broad estimate with 10 buckets already, which is still a lot for a conventional histogram, and usually you have even fewer buckets. So this is so much better than before. There's also average calculation, which is sum and count of the histogram. It's the same as sum and count of a summary, so this is not specific to histograms, but there's a problem now with the new histograms. How do I even access the count and the sum, which is now part of the bigger structure? Right now there are functions for that. here, histogram sum and histogram count. You extract them in the end, because if you do it first, then you cannot take a range selector on them. That's the old thing. So you have to rate the whole histogram, and then you extract the sum and the count. Graphs look exactly the same, because that's exactly the same math and the same data. The advantage now is no namespace pollution anymore with like magic suffixes, and it also works with negative observations. If you don't know what this is, you don't have to worry, but the histogram specialists, they know what the problem is here. In the future, I have this wild idea that we could have like dot operator to access fields of such a structure. So this would be quite nice. Syntax-wise, it looks originally like the same as the original one, just that underscore is now a dot. Maybe that might work. It needs a bit of thought. We have reserved the dot operator in PromQL. I thought for this purpose, maybe that's just my idea, but we'll see. So that doesn't work yet, might work in the future. Okay, final thing, fraction calculation. That's what I usually think is more important than even quantile calculation. The typical thing, you have an SLO of serving requests in 250 milliseconds. Like you want to serve 99% in 250 milliseconds or less. So the question you ask is, what percentage of queries have I actually served at 250 milliseconds or less? With the old histograms, if you have a bucket there, great, right? It's a very natural PromQL query. For the new histograms, you need a new function, once more, histogram fraction. This works in precisely the same way, because 0.25 was deliberately chosen. It's a quarter of 1, so it's kind of this power of 2 whatever thing. But usually you wouldn't have a bucket boundary at this precise value. Then histogram fraction will automatically do an interpolation, which works quite well, and it's quite accurate because you have usually this high resolution. But with the old histograms, if that's a big if, you have the right bucket boundary, it works precisely. With the new ones, Ganesh mentioned that, you can't like have custom definitions of bucket boundaries. So it's kind of a little drawback, which maybe we fix in the future. But yeah, still, usually you fix a bucket and then later you change your SLO and it doesn't work anyway. And with the new one, you always get a fairly accurate estimate. All right, I think that was everything you can do with PromQL and the native histograms right now. Not everything is supported, but I guess 99% of the use cases should work. So play with it, have fun, and thank you.
Hey, thank you. First of all, I know you've been working on this for 2 years, you and Ganesh, so thank you again for making all of this possible. Yeah, so the question is on the fraction, histogram fraction, compared to the counter where you have the LE bucket in the counter and then do this query. How's the performance compared? Like, is it like way faster now with the fraction function, or is it like even worse? Like, this is in a lot of places on the stuff I do, so I'm just curious on how it like compares in performance.
I would estimate that right now the performance must be worse, because previously you have the right time series already in place, right? It's a very simple operation on the left side. On the right side, you have to go through the whole histogram. You have to find the suitable buckets, but since the whole histogram is like saved as a big blob, you have to decode everything. I could see that this might be done in a, I don't know, for the count and the sum, which is the average calculation, right? This one here. I could see that we maybe store them. I mean, we can do all the optimizations under the hood if we want to. Store them separately. You don't have to decode the whole histogram, who knows? Here, yeah, you have to dive into the histogram. Like, so if you know super precisely that you want this boundary, the conventional histograms might be the right way to do, right? So they might not go away in a way, because for those very static use cases, they are good, right? Essentially, if you find yourself only defining 2 or 3 buckets and you're happy with it, it's probably a good use case for the conventional histograms. If you don't know where this will happen and you want to look at it with a different threshold later, and then you just do this, the query itself kind of inevitably has to be more expensive. But I hope it will still all be feasible. We'll see if you all try this out in like large-scale setups now, how well you will fare.
Hi. Just have a question regarding the what's called the floats and the histograms, like types. So I'm more like interested about like if there will be any pollution of the floats on the histograms. So for example, like you mentioned, when you use the sum, when you use the rate, like on the different two types. And that just like didn't give any output. But then for the other, for example, for the other PromQL queries that you did, like it showed an output without any problems. And my question is more like, can I use like a PromQL query where I can specify that I want this query to run over like the histogram types and not like the floats? Because like you said, like I cannot control that the targets will bring me like the same name of the query of the metric with a float or with a histogram. If you understand my question.
Yeah, it's very hard to hear what's like if the speakers are weird here. But anyway, what I understood is you kind of want some control that you can say, I only want the real histograms and want to put them into the aggregation and not any rogue float time series that might have.
Yes, exactly.
Yeah, so this is a good question. If we went down this like static typing approach, we would have some other syntax for histograms, right? Where you just access them in a different way. There might be some, I mean, this still has to be matured, and as said in the disclaimer, this could all change, right, if we find out that was a bad idea. Hopefully not, but we'll see. There might be some filtering in a way, right, that you say only give me histograms and then aggregate them or something, right? Maybe that might be a way to do this. I assume in practice that this will rarely happen, right? Because typically a histogram is named like a counter just without the total. So in practice, it might not be a big issue. And of course, you should get a warning if you run into it, and then you should clean it up. But maybe, yeah, we have to see what the use cases are. If like a lot of people run into this and they want this filter function of some kind, then yes, that might be something to add. There's also a bit more like, in a way, and that gets like PromQL philosophy, in a way we were already dynamically typing because we had counters and gauges, right? And they all looked like floats, and we would just like rate a gauge all the time, and we wouldn't notice. And typical thing, like people accidentally do this and get weird results. So in a way we could extend this, like if this had been a longer talk, I would have talked about this a lot, and have this type information there as well as dynamic typing. This is a gauge and not a counter, and if you rate the gauge, it should not give you a result, and it should give you a warning. And then you have the same problem of what you just said, right? If there's a gauge in my mix, and then we might also have this like coercion function, right, where you say only retrieve this if it's actually a counter. So that might be interesting stuff coming up in the future with a bit of new style PromQL. But yeah, it's still like more research needed, essentially.
So I think my question is actually a follow-on from that question, but I was going to ask, is there going to be, like in the same way we have is_nan, is there going to be like a is histogram or is float? Because then you could potentially use that as your filter.
Essentially, yeah, that would be a filtering function that essentially tells you only, like, remove this element from the vector if it's not a histogram, which could also be remove this element if it's not a gauge or something, right? It's kind of equivalent, and this might be a whole class of filtering that we introduced to PromQL. But this is all like up in the air right now, right? I'm not promising anything.
Just similar to the other follow-up, what about just using a label? Similar to __name, maybe __type?
Maybe. I mean, we'll see. It's it could be. We are also thinking about richer metadata, and this type of information could be there. Yeah, it's kind of PromQL. It's growing up, right? It gets all those interesting, gets into those interesting problem domains now.
Thank you. Can you hear me? Oh, yeah. Okay. Thank you for your talk. I want to ask in this particular slide, the histogram fraction, you have 0.25. But now that we have somehow dynamic buckets, will it use the floor or the sail of the actual bucket? So say we want to see the percentage of requests that succeed in 0.25 seconds, but now we don't have a bucket that is exactly at the 0.25 seconds. Will it, like, is it going to select 0.2 or 0.3, right? Like whatever we have as a bucket. Is this the sail or the floor?
Okay, it's hard, again, it's really hard to understand what people are saying here up on stage. I understood you were wondering, I guess that was the fraction, histogram fraction function, which bucket boundaries it will pick.
Exactly.
It will, I mean, if you happen that your boundaries that you specify are coinciding with the bucket boundary, it will take that one, but otherwise it will do interpolation, which right now it's just doing linear interpolation, which is stupid for exponential buckets. That's also like details that we have to hammer out. It should use some exponential interpolation function. There are many, like there are different theories how to do this best, and we are still investigating what to do. We just do the linear thing because it was already in place, but it should be some exponential interpolation. But it's doing interpolation, right? And it's another thing that we might need to make queryable, that you find out what the current bucket resolution is, so you can give an error estimate, which is also right now there's no way of finding out with PromQL what the actual resolution is. You can query the histogram and look at the output to get an idea, but there might be also some power user PromQL functions that tell you what the expected error is for that estimation or something like that.
Yeah, exactly. That was my second question, actually. If there is some type of feature that you will introduce to understand the actual error that you would expect with a specific boundary that you specified based on the actual resolution that exists on the bucket. Yeah. Okay, thank you.
Okay. Okay.
Thanks, Björn. So my question is, can you share maybe some story behind how hard it was to design that? How many different options you had to choose? Was it stressful, exciting? Like how many different alternatives you have thought through? Okay. Tell us some kind of story behind that. Yeah.
I mean, you want me to give one of those talks from the original trilogy right now. So I mean, this essentially, like especially this last PromCon talk in Munich, this was going through a number of options that we considered. I mean, it was a weird thing. The very short version is we introduced the existing histogram. Back then it was just like, we want some histograms, this is just a prototype, and we will soon create proper histograms. And then, I mean, they were good enough for many things, and they brought us quite, like, yeah, we went quite far with those, but we always had this in mind that this is not the end of the story. But there are so many, like, this is like a rich area of research, and there are a lot of very advanced algorithms, but they don't necessarily work in the Prometheus context, and even what we have now. This is very similar to what metric vendors already offer for a while, but then again, they have this like, they push for 1 minute the data to the vendor, right? And then they have a very different view of the world than with Prometheus, where anyone can scrape at any time, and that's all in this second talk of that trilogy, where it wasn't even clear if that would work out for Prometheus, and yeah, it worked out. It has to do with entropy and how it accumulates, and it's really interesting. And was it stressful? I don't know. It was probably fun, but it took way too long, but also because there are always so many other things to do. If we just worked on histogram from the beginning, we would have had them 5 years earlier, I guess, but yeah, there are also other features. All right, we're probably way out of time now.
Yes, we are a little bit over time, so...